you plan to order tacos and hamburgers for a group. Hamburgers are $5, tacos are $2. You want a minimum, that's kind of important, a minimum of 10 items. So the least you want is 10 items for your group. And you want to spend at most $30. So you don't want to be over $30. So that's kind of important, those two ideas. All four are really important, but these two are kind of, that most and minimum are kind of important. We're going to create a graph and also write a sentence to describe one combination. Now, some of you could figure this out just by logic. You could just try numbers, meaning, well, if I want to spend at most $30 and I want a minimum of 10 items, well, if we think about that, could you just logically go, oh, if I want a minimum of 10 items, so could you just do 10 of something and get under $30? What could you buy 10 of these two, and get under $30? So under $30 and a minimum of 10 items, so would that be 10 tacos? Would 10 tacos work?
Yes.
So could I answer the second part there already? 10 tacos, would that work?
But
10 tacos, 0 hamburgers would work. But I'm going to do a mathematical way with the graph so you can see more answers. Okay? Could you even do 9 tacos and 1 hamburger? If you try the numbers, it might work. You can try different combinations of it and see what happens. We're going to do a graph to relate it, but a lot of you could understand logically that, oh yeah, if I just do 10 tacos, it'd be $20, which is less than $30. And that's a logical way to get part of it. But we're going to do a mathy way to solve this. So, what I'm going to do is create 2 equations, or these are inequalities. I'm going to use the letters T for taco, and I'm going to use the letter H for, what do you think? Hamburgers. So, and when I say tacos, I'm saying the number of tacos and the number of hamburgers. I should have clarified that. That pound sign means number. So when I say T, I'm saying a number of tacos. So if I say 8 tacos, that means T is 8. If I say I have 8 hamburgers, that's H is 8. So the number of tacos, the number of hamburgers, I'm using these letters instead of X and Y. Okay, now, what would be, for this equation, what is T plus H? The number of tacos plus the number of hamburgers, what does it say it has to be? A minimum of 10. So when we add our tacos and our hamburgers together, it's a minimum of 10. So how do you say a minimum of 10? Would this have to be bigger than 10 or less than 10? If we're saying a minimum of 10.
less or equal to.
Wouldn't this number, for this to be a minimum of 10, wouldn't this have to be bigger than 10? If 10 is the smallest you could have, wouldn't these two have to be bigger? Just think about that for a second. Wouldn't the tacos plus hamburgers have to add up to be more than 10? For instance, could you give me, if you have a minimum of 10 items, how many tacos and hamburgers would add up to more than 10 items? Well, 500 tacos and 85,000 hamburgers would be bigger than 10 items. It's kind of a lot. But you just got to add these two numbers, and they have to be bigger than 10. All right, now I'm going to make another inequality. How much is a taco? Well, aren't tacos $2? So wouldn't 2t give me the cost of tacos? So if I bought, let's think what 2 times t means. If I bought 5 tacos, wouldn't that be 2 times 5 be $10? Mm-hmm. If I bought 10 tacos, wouldn't that be 10 times 2 is $20? Do you understand 2t represents the price of t tacos? So how would you do hamburgers? Well, how much is a hamburger? So 5. So I have $2 per taco plus $5 per hamburger. So if I bought 1 taco and 1 hamburger, wouldn't that be 2 times 1 is 2, plus 5 times 1 is 5, so that'd be $7?
Yeah.
I bought 2 of each, that'd be a 2 here and a 2 here. So that'd be $4 plus $10, that'd be $14. So I kind of shows the idea. Now, what are we at most, how much are we trying to spend? 30. So I don't want to spend more than 30. So wouldn't this be 30 here? And doesn't this have to be at most 30? So wouldn't that mean I want this to be smaller than 30? So this can be a little tricky, but are you okay that we want that? Don't you want the cost here of tacos and hamburgers to be below 30 bucks? Because you don't have that much money to spend. I now have created 2 inequalities, which I'm going to graph here. Now, to graph this, I have to stop and think. I have 2 inequalities. I don't have x and y here. I have t and h. So we get to choose which is t, which is h. So I'm just going to call this tacos and call this hamburgers. I'm not going to label them quite yet. Now, by the way, we're only going to be the axes. By the way, this is the axes we're using. Are you okay we're only in the first quadrant? Because could we have negative numbers? Could I have negative tacos or negative hamburgers? So are you okay we're only in the first quadrant? I'm not going to put the numbers yet because I want to think about what are possible numbers we're dealing with for graphing this. Because I might have to go by 2s or 3s or something. So I'm holding off. But are you okay if we have hamburgers and tacos? Yeah. Does it matter? Could I put tacos here and hamburgers here? Does it matter which is which? Not really. I'm just going with what I put. So to graph these, I'm going to try to get each of these equations to be either h equals or t equals. Kind of like a graph is always y equals. So to get y equals, or y by itself, well, there's no y here. Well, isn't this your y-axis, the vertical? Do you guys know that? Isn't your y-axis the vertical? And what letter is that? H. So don't I want to get h by itself? In the end, I want h blank. Instead, because normally it's y, right? Isn't it normally this, the letter on the left by itself, and then the x is over on the other side? So I want to get h by itself. So let's focus on this one. How can I get h by itself? Well, can I minus the t over? So watch. If I simply go, oh, t plus h is greater than or equal to 10, could I simply minus t over? And I now have h is greater than or equal to negative t plus 10. That right there is something we're going to graph. Is it in an inequality format that we could graph, kind of like y equals? So there's one of them. My other one is I got to rewrite this one so I get h by itself. So for this one do I get h by itself? Don't you minus the 2x over, the 2t over? So can I minus the 2t over? And I now have 5h is less than or equal to negative 2t plus 30. Okay, how do I get rid of the 5 on the h? You divide it off. So could I divide everything by 5? So what I now have is h. Do I flip the inequality? Did we divide by a negative? No. I have negative 2/5. That's a slope. T. I should put capital T since I'm using capitals. And what's 30 divided by 5? 6. So what I have here are 2 functions, not functions, they're inequalities, that I can now graph. And that's what we're going to do next. We're going to graph those here, and that's going to help us get a picture of how to solve this. So we're going to graph these 2 next. Alrighty. So for this one, I'm going to graph these 2 functions. If you look at the y-intercepts, that starts at 10, that starts at 6. So the y-axis, I have to be able to fit at 10. So I can't go by 1s, so I'm going to go by 2s. So it's 2 hamburgers, 4 hamburgers, 6, 8, and 10. And on the other axis, I'm just going to go by 1s. I think that should fit. Tacos, I'm going to go by 1s. All right. So, actually, I just realized, no, I don't want to go by ones. Yep, 4, 2. Let's think about this. What do we want to go by? You know, I'm going to go by 2s on both. There's a reason. Hopefully it all works out nicely. I think it'll be better. So, let's graph the first graph. So what's our y-intercept for this first one? Isn't it 10? So can I put a dot at 10? And then my slope is what? Well, isn't there really a 1 right here? Isn't that a negative 1 slope? So doesn't that mean I'm going to go down 1 over 1, down 1 over 1, down 1 over 1? Can you see how it starts looking like this? I'm just going to go down 1 over 1 repeatedly. Now, is it a solid or dotted line? What's that tell you? Solid. So I'm going to make a nice solid line through that. And what side am I going to shade? What is that, a greater or a lesser? It's a greater. So I'm going to lightly shade this side. So I now have graphed this one. And I still want to graph the other one. So next, I want to graph this one. So isn't my y-intercept 6? I'm going to do this one in red. So I'm going to make this one in red right here. So I'm going to start at 6. And what does my slope say? My slope says to go down 2 over 5. So from here, could I go down 2 and over 5 right there? Down 2 over 5. And then can I do that again? Down 2 over 5. Okay. And is it dotted or solid? What's that little sign say? That's a solid line because or equal to, so we make a solid line. And what side are we shading? It doesn't say less than or equal to. So won't that mean under? So we're lightly going to shade this. Do you see a spot where it's overlapping?
Yeah.
That is where we're going to darken. This little space that we overlap in is important. That is the key right there. Now, what is all this saying? What does this shaded region represent? It represents spaces where this is true, which is this last sentence. Write a sentence of possible combinations. Meaning, could somebody give me a coordinate in this little area? Or on the edge of the area, because they're solid lines. Well, is this a coordinate right here? Is that right there? Is 10, 0 a coordinate? So could I do 10, 0? Is that a coordinate in there? Yeah. How about, could I also do 10, 1? Is 10, 1 also a coordinate? What about 10, 2? Is that a coordinate? Even though it's on the edge, is that still included? Can you find some coordinates in that little shaded region? Are there a lot of them? No. But right here it's kind of hard, but could I technically find one right here? Is there one right there? What would that be? 9, 2? Now, why am I writing all these coordinates? All those coordinates are true. And here's what they mean. Isn't this, look back, isn't this, what's the first number? Isn't it tacos and hamburgers, you guys? Think about that. Isn't this your tacos, your x-axis? Isn't your x-axis tacos? Isn't your y-axis hamburgers? So if I bought 9 tacos and 2 hamburgers, that follows what they said. Would I be under $30 at 9 tacos and 2 hamburgers? At 9 tacos and 2 hamburgers, would I be under my $30 limit? Yes. If I bought 10 tacos, remember these are tacos and hamburgers, and 1 hamburger, would I be under my limit of $30? Do you catch the idea? Any coordinate in this little blue shaded region, these are all the coordinates, are possible combinations of tacos, hamburgers that I could buy under 30, but a minimum of 10. I just found a whole bunch of possibilities. Now, you could have done this by guessing. Guess, 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 guess. But this is a mathematical way to draw a picture and to find a whole bunch more possibilities besides just guessing. So for this last sentence, you got to choose any of these or more and say those are your possible combinations. So we just choose one. I'm going to choose this one, 9, 2. So what would work is I could have 9 tacos and 2 hamburgers. You don't need a full sentence. It could be a phrase. That's what would work. 9 tacos and 2 hamburgers. Now, could I, again, put 10 tacos and 0 hamburgers? Could I put any of these sets of numbers? Yeah. So what do you do on this test? You first have to kind of set up your equations, your inequalities. Then you got to set them up so you can graph them. And then you got to look for this little shaded region. That shaded region represents what's possible in context. The possible combinations of purchases that will work.